Hello again. Uh, I hope everybody's doing well. Today I want to talk about PN junction diodes, or PN junctions first, which basically is the same thing as a diode, as we shall see. I want to start by summarizing the videos that I've already asked you to watch very briefly, because hopefully you've already watched them. The main material that we use in semiconductors, which include diodes and transistors, it's primarily silicon. Now there are other materials that can be used, but this is primarily the main one. A good conductor is something that has one or two valence electrons. What does valence mean? That means the number of electrons in its outermost shell. Now, atoms seem to act most stable when they have their outermost shell that has any electrons at all in it full. That means zero valence electrons. Anything with zero valence electrons is a good insulator. But something that has one or two valence electrons will give up those one or two electrons very easily with applied voltage and allow a current to flow. So that would be a good conductor. Silicon's kind of halfway in between. Get the wrong primary, sorry. Silicon, chemical symbol Si, it has 14 protons in the nucleus. That means it needs 14 electrons. The first shell holds 2. The second shell holds 8 for a total of 10 so far. So the next shell would like to have 8. Actually, the next shell, the third shell, has 3 subshells, but we're only going to deal with the first subshell in discussing silicon. It has 4 electrons. And of course, electrons are negatively charged. Now, if you put a bunch of silicon atoms together, they will share electrons with each other. In other words, you put a bunch of silicon atoms together, each atom will share with exactly 4 of its neighbors 1 electron apiece. So here I've got a neighbor, and they're going to share an electron between the 2 of them. Up here there's another neighbor, and they're going to share that pair of electrons, one from this atom, one from that atom, and so on with 2 more. And every atom will do that, so each silicon atom now thinks that it has 8 electrons in its outermost shell, so it's very stable and happy. This kind of structure, well, first of all, we call this type of bonding between atoms, keep on the slide the screen up, sorry, covalent bonding. And the structure that is created by that is called a crystal lattice. Lift off the L there. So we form this crystal lattice. Now since each atom thinks it has its outer shell full, they're not going to give up another electron very easily. So this is actually a pretty good insulator. Now, to make what we call a semiconductor, we use a process called doping to implant impurity atoms into this crystal lattice structure. First of all, let's take an example of an impurity atom that has, instead of 4 valence electrons like silicon, has 5. I'm going to abbreviate that. We call those pentavalent atoms. But penta means 5, A-T-O. Let's erase that and do better. Lost my marker there.